In this video, we'll look at finding the derivative of the exponential functions. What about these functions? There are another set of simple functions that we might be able to use to find derivatives of. So we're going to start with the natural function e to the x, and we'll wrap up the other ones later. So if we look at the function e to the x, I want to find its derivative. How do I do that? Do that from a definition. So the derivative here should be the limit as h goes to 0, f of x plus h minus f of x all over h. We can plug in our function to get e to the x plus h minus e to the x all over h. And I can simplify this a little bit by pulling an e to the x out of the top, because e to the x plus h is e to the x times e to the h, so I can factor e to the x there and factor out of everything there. So then I'll get this as the limit as h goes to 0 of e to the x times e to the h minus 1 all over h. And since this e to the x does not depend on h, and my limit isn't h, I can move that out front too. So I'll have e to the x times the limit as h goes to 0 of e to the h minus 1 over h. The question really comes down to, what is this limit? One way to figure this out is looking at how e is defined. So e is a number defined by a limit. It's defined by the limit as n goes to infinity of 1 plus 1 over n to the n. This is the idea of continuously compounded interest, right? As I take n bigger and bigger, I'm taking more and more subsections and compounding it more times. So e is the limit I get for compounding continuously. Now if we take this definition here for e and do some hand-wave manipulation here, we can get then that this means then that e to the 1 over n looks something like 1 plus 1 over n, taking the nth root to both sides. I can then subtract 1 from both sides to get that e to the 1 over n minus 1 is about like 1 over n. So then e to the 1 over n minus 1 over n looks like the number 1. And if I replace h with 1 over n, since we're doing the same thing, n is going to infinity, and 1 over n is then going to 0, which is what h does up here, that motivates that this limit here boxed in green is 1. So this whole thing is 1, which means my answer here is just e to the x. You have to really understand how all of that works, but the point is, the rule we get from this is that if I take my function to be e to the x, its derivative is also e to the x. So e to the x is a function that is its own derivative. And that's a rule you can know and use going forward trying to find derivatives of functions that involve e to the x. They can be e to the x plus a polynomial, but we have linearity, so I can separate those two and do the two separately to get my final answer.